We're going to get started on our first activity for 4.3, which is we are still solving systems. We're going to talk about one final method, which is the elimination method. So we have done it through graphing, we have done substitution, and now we're going to do a method that's called elimination. After you put your name on that first slide, push ahead to slide 2. So in the substitution method that we did last week, we first had to solve for one of the variables. If all of the variables have coefficients other than 1, it can get messy. We may deal with fractions. And when you attempt, like I said, to solve for x or for y, fractions will be everywhere. So you can avoid dealing with fractions with another method called the elimination method. The goal of the elimination method is to create two equations so that when you add them together, one of the variables is going to cancel out or add to 0. Push ahead to slide 3. So here's the two equations we have here. So the elimination method eliminates a variable by adding the equation. So the goal of the elimination method is to create two equations so that when you add them together, one of the variables cancels out. So we're going to first practice with some that are all ready to be added together and cancel out, and we'll look at more advanced ones a little bit later. So we have these two equations here, 2x plus 3y equals 2 and 9x minus 3y equals 42. So what we notice is that we have a positive 3y and a negative 3y. And that is perfect. When that happens, when we have the same coefficient, but one is positive, one is negative, when we add them, they will cancel out. So we have 2x plus 9x gets us 11x. 3y plus negative 3y cancels to 0y. Gone. Equals 2 plus 42 is 44. And now we have this really simple one-step equation. So 11 times what is 44? Well, we'll just divide both sides by 11. 11 divided by 11 is 1. So we just have 1x equals 44 divided by 11 is 4. And just like that, we have one of our coordinates for the system. And to find the second one, just like in substitution, we'll plug it into either equation. So I'll choose the first equation, but again, it doesn't matter. 2x plus 3y equals 2. I like this one because there's all positives and the numbers are smaller. So that's fine. We can choose it just because of that, but it doesn't matter which equation we choose. We'll get the same answer. So we're going to plug in 4 for x. So we have 2 times 4, which is 8, plus 3y equals 2. Ooh, I'm sorry about that. Something just fell on my desk. We can then subtract 8 from both sides. And we get 3y equals 2 minus 8 is a negative 6. And then we'll just divide both sides by 3, and we get y equals negative 2. So our full coordinate for this answer is 4, negative 2. Beautiful. And that is our first example with the elimination method. Once you feel good, you have everything that you need, you can push ahead to slide 4. Remember that you can always do this on paper and send me a picture. If that feels better to you, that's always an option. And you can also always pause the video whenever you need to as we're working through it, if you need to take a break or if you need some more time to catch up on the notes. So this next one is 2x minus y equals 16 and x plus y equals 5. So I see negative y, positive y. So we have a coefficient that's a -1 and a +1, which is great because when we add them, that means they will cancel out and eliminate. 2x plus 1x gets us 3x. -1y plus 1y cancels to 0, equals 16, plus 5 is 21. Now, one-step equation, we'll just divide both sides by 3 to get x alone. So we get x equals 7. Just like that, again, we have our first part of the coordinate of our solution, which is going to be 7, comma, something. For this one, I would choose the equation x plus y equals 5. That's nice and simple equation, and we can plug in 7 for x. So 7 plus y equals 5. So it must be a negative number. We're going to subtract 7 on both sides to solve for y. 7 minus 7 is 0, and we get y equals a -2. So our coordinate is 7, comma, -2. And at that point, we are done. So we have these steps over to the side. This is a nice little box that can be helpful, kind of giving us like a one-word quick summary of how we're working through this problem. So first we look, we notice that -y and y would cancel out, so we're going to choose to cancel out y. We don't need to multiply anything. We'll see that a little later. These are already going to cancel out on their own, so all we go right to adding, and then we solve, and then we substitute it in, and we can check our answers, right? 7 plus -2, that does equal 5. 2 times 7 is 14, minus a -2 is 14 plus 2, which does equal 16. It works for both of our equations. It is the solution to the system. Push ahead to slide 5. Okay, elimination method here, eliminate a variable by adding the equations. So we have an x and an x, and a -2y and a y. So right now, they're not going to cancel out right away. So we can choose, do we want to eliminate the x or the y? So I'm going to choose y. I see there's this -2y. So I need this second y to be a +2. So what I'm going to do is I'm going to multiply this entire equation by 2. So we get 2x plus 2y equals 12. And now I'm going to add that to our first equation, which was x minus 2y equals -6. Now notice we have a +2y and a -2y. Great. So we look, we chose y, we multiplied one of the equations by a number so that when we add them, which we're going to do next, it will cancel out. 2x plus 1x is 3x. 2y plus -2y cancels to 0, equals 12 plus a -6, or 12 minus 6 is 6. Divide both sides by 3, and we end up with x equals 2. So there's our first part of the coordinate. Now we can use either equation to find our y coordinate. So we do have this nice simple one, which is just x plus y equals 6. And now we know x is 2, so 2 plus y equals 6. Subtract 2 on both sides, and we'll get that our y coordinate is 4. So our solution is 2, 4. Beautiful. So this one was a little more advanced in that we had to do a little multiplying before we added those equations. Okay. Push ahead to the next slide when you're ready. Okay, we have a negative 3x plus 2y equals 3, and 4x plus 3y equals negative 4. So we're looking, they're not going to cancel out right away, right? So what we need to do is we need to choose which variable we want to be working with. Now I do notice that we have a negative and a positive for our x's, so that could work out pretty nicely. So I think I'm going to choose to eliminate x. Now, right now it's a 3 and a 4, and we need them to be the same number. And I know 3 times 4 is 12, right? So I'm going to multiply this first equation by a 4, and I'm going to multiply this second equation by a 3. And now we can do this. We're not changing the equation. We're writing an equivalent system just by multiplying everything in the equation by the same number. So 4 times negative 3 is a negative 12x, plus 4 times 2y is 8y, equals 4 times 3, which is 12. In our second equation, 3 times 4x is 12x, plus 3 times 3y is 9y, equals 3 times negative 4 is negative 12. Great. So now I can see, hey, we have a negative 12x and a 12x. So when we add them, we're going to be in business. So let's add these two equations. Negative 12x plus 12x cancels to 0. 8y plus 9y is 17y, equals 12 plus negative 12 is also 0. So if we divide both sides by 17, we get y equals 0. 0 divided by 17 is 0. So our y coordinate of our solution is 0. Now to find the x, I'm just going to pick one of the equations. I'll pick the second one, 4x plus 3y equals negative 4. And I'm plugging in 0 for y. So we have 4x plus 3 times 0 is 0, so it cancels out. So we just have equals negative 4. Divide everything by 4, and we get x equals negative 1. So our coordinate, the system solution, is negative 1, comma, 0. Beautiful. When you're all set, we'll do one more in this video. Push ahead to slide 7. We have a 3x and a 6x, and then we have a 2y and a 4y. So at this point, again, we just choose which variable do we want to eliminate. I'm going to choose y. So I have a positive 4y here. So I want to make that top one a negative 4y. And the way I'm going to do that is I'm going to multiply 2 by negative 2. And when we do that, we get a negative 6x plus a negative 4y equals a negative 12. And our second equation was 6x plus 4y equals 12. This is interesting. So when we add these two equations, negative 6x plus 6x is 0. Negative 4y plus 4y is also 0. And negative 12 plus 12 is 0. So we get 0 equals 0. And 0 equals 0 is a true statement. And what this means is we have infinite solutions. So that means that these are actually the same line. So these two equations are actually the same line. So this is infinite solutions.